This video is to allow you to correct your homework from section 1.1.5. Starting with 136, Bob and Mark decided to try the peanut and raisin investigation at home. Bob started with 10 peanuts on his tray, and Mark started with 10 raisins on his tray, as shown. So the dark are representing the raisins, the light are representing the peanuts. Here's Bob's 10 peanuts, Mark's 10 raisins. Mark gave 3 raisins to Bob as shown. So they've drawn sort of a loop around 3 of the raisins and put them onto Bob's tray. How does the number of peanuts and raisins on Bob's tray compare to the number of peanuts and raisins on Mark's tray? So you could say Bob now has 10 peanuts and 3 raisins. Mark has no peanuts and has 7 raisins. So Bob has all the peanuts, all 10, and he's got 3 raisins. Mark has no peanuts, but he has 7 raisins, pardon me. Then they want you to copy what we have here. So put that into your homework doc. Circle a group of any 3 peanuts and raisins on Bob's tray. So you could use your drawing tool to do this, or you could do this in your notebook and take a picture. But they want you to circle 3 from Bob's tray to put back onto Mark's tray. Now, you could circle the 3 raisins again. You could circle 3 peanuts. You could circle a combination of peanuts and raisins. But what they want to know is, does Bob now have more of Mark's raisins, or does Mark have more of Bob's peanuts? Now, do not copy what I have here, because this is just what CPM is saying in terms of understanding what we're looking for. They want you to recognize that Bob should have the same number of Mark's raisins as Mark has of Bob's peanuts. But again, be specific. So let's say you put those 3 raisins back. Well, now Bob would have 10 peanuts and Mark would be back to 10 raisins. And neither would have either of the other. Or let's say you put 3 peanuts onto Mark's tray. Well, now Bob would have 7 peanuts and 3 raisins, and Mark would have 7 raisins and 3 peanuts. So the number of raisins that Mark gave to Bob is the same as the number of peanuts that Bob gave to Mark, or again, a combination. So make sure you're specific here as to what you did, and then ultimately you should see that the number of raisins that Mark has is equal to the number of peanuts that Bob has. Then they want you to go back to do that again, and this time assume that 8 of them need to be transferred and explain your results. So again, go back to this very starting point here. Take 8 from Mark in terms of raisins, put them onto Bob's tray, show what you now have or say what you now have. Then take 8 from Bob's tray, put them back on Mark's tray. Again, be specific about what you now have. How many does Bob now have of Mark's raisins? How many does Mark now have of Bob's peanuts? They should be the same as each other. So for this one, Eli walked 12 feet down the hall of his house to get to the door. He continued in a straight line out the door and across the yard to the mailbox, which is 32 feet. He came straight back across the yard 14 feet and stopped to pet his dog. So the first thing they want you to do is make a diagram. So this is my basic diagram. So this is the hallway, 12 feet. Here's the edge of the house. This is the 32 feet to go to the mailbox across the yard. And then he's coming back another 14 feet and petting the dog. How far has he walked? Well, he's walked the 12 feet down the hallway. He's walked the 32 feet to the mailbox, and he's walked the 14 feet back. So don't just put the 58 feet. Put how you got that. And then how far is he from the house now? Well, basically, this was 32 feet from the house to the mailbox, and he's gone back 14 feet towards the house. So again, show how you got 18 feet from the house. For 138, they want you to look at these 2 pictures and see that one of them is not correctly showing 1/3 and explain why. They're also letting you know that in the entire CPM series, whenever you see this symbol, it's going to be a sign that there's been a mistake. It's a commonly made mistake, and they want you to explain why there's that mistake. Because when you explain why something's a mistake, you're less likely to make that same mistake yourself. So in this case, The mistake is in this circle. This has not been evenly divided into thirds. The two outside parts are not equal in size to the inside. This circle is divided correctly into thirds. This is the way we divide a circle into thirds. Here you have to find the pattern in the number. Use your pattern to generate the next 5 numbers in the sequence. Now for this first one, they look at it as 2, and then every other, this is 3, every other, this is 4, this one would be 5, this one would be 6, and that you have the same thing every other here, 5, 6, 7, 8, and 9. Okay. If you have those numbers, that's correct. And then if you explained it that way, you'd be saying that every other number is a consecutive counting number. Now, what do we mean by that? Well, every other means the greens are every other and the yellows are every other. Consecutive means one right after the other, like 7, 8, 9, or 5, 6, 7, 8, 9. Those are consecutive. Counting just means that they are whole numbers. The other way that some people have described the pattern is that they view it as adding 3, then subtracting 2, then adding 3, then subtracting 2. That will also work, but then you need to find a way to also explain that pattern, that for each subsequent term, we call them, or the next term, you're adding 3, and then after that, you're subtracting 2, and then the next term adding 3 and subtracting 2. Here, for the pattern, you can see that we're subtracting 1, subtracting 2, subtracting 3, subtracting 4. So the remaining numbers would be these: 85, 79, 72, 64, 55. And again, your explanation, they're using some good math vocabulary here. You're subtracting consecutive counting numbers from the previous term. So what that means is you're subtracting 1, then you're subtracting 2. So that's what they mean by subtracting consecutive counting numbers. Previous term means the one in front of it. So we subtracted 1 from 100 to get 99. We subtracted 2 from 99 to get 97. Now, when you round, I want to remind you of how I typically talk about doing it. I'm going to look at C with you. So you have 285 and 39,154 hundred thousandths. Okay. They want us to round this to the nearest hundredth. I apologize for this being a little messy, but I'm trying to do it with my mouse. So first thing I suggest students do is underline the place value that we want, which is the hundredths. Well, that's 2 places behind the decimal point. Then I do an arrow to the number to the right of that. I call that number an indicator number. Indicator number indicates whether we round up or down. So the general rule for rounding is everything in front of the number you're going to round stays as it is. So 285 stays as it is, decimal, and the 3. Then, to decide what to do with this digit in the hundredths place that we're going to look at rounding, we look to the right of that. Well, it is a 1 that's to the right of that. The indicator number is a 1. If the indicator number is 4 or less, we round down. When we round down, it does not mean we take the 9 and make it an 8. It means we take the 9 and we leave it a 9. So that number stays 9. If this had been 5 or above, we would have rounded up. And then once the indicator number has done its job, it and everything behind it becomes zeros, or if they're behind a decimal point, they can actually just drop off. So to me, that's a good explanation for how to do your rounding problems. So now for this first one, it's a little bit tricky in that the 10,000ths place is here, which is the 9. The indicator number is the 6. We still follow the same rules. So 33 stays as it is. So does the 5 and 4. But what gets a little bit tricky is, and this doesn't occur that often, but the indicator number tells us to round up, but yet we have a 9 here. And if we're going to round a 9 up, it's going to become a 10. So what happens is that becomes a 10, but you can't have a 10 in a single digit. So you put a 0 here and you round this one up as well. So basically it goes from like 29 to 30. So again, that doesn't happen very often where you have to round up and then it's also a 9 that's being rounded up, but that's how you handle it if you do. For B, the thousands place would be the 7. The indicator number is the 4. So the 3 and the 0 stay as they are. 4 tells us to round down, which means the 7 stays as it is. The 4 is done its job as an indicator number. It and everything behind it becomes zeros. And then here, they want us to round to the tens place, which is here. Indicator number is the 1. So again, the 6 and 8 stay as they are. The indicator number tells us to round down, so the 1 stays as it is. The indicator number has done its job, so it and everything behind it becomes zeros. Or if they're also behind the decimal point, we can actually just drop them off. So that would be a explanation of how to correct that. Please pause the video wherever you feel you need to make sure you get the information down. Thanks.